Hi everyone, welcome to Unit8 Talks, a webinar series on data and AI. For those of you who are new to the series, in a couple of words, we're Unit8, a Swiss data analytics and AI company, driving the adoption of data science in the industry and committed to sharing our best practice. And this is what we're going to be doing today. So this session is for you. Please ask any question you have using the Q&A panel on your left-hand side. The session is recorded. You'll receive by email a link to the recording, and we'll upload it as well on our YouTube channel for public viewing. Without any further delay, today's topic is about data science platforms, their design best practices, and to talk about that, we've gathered our Unit8 experts to share their experience on the matter. Marek, Matthias, Tomek, the floor is yours.
Thanks, Samir. Hi, everyone. My name is Tomek, and as Samir said, together with Matthias and Marek, we'll be talking about 6 considerations when designing a data science platform. Let's begin. And so we start with a bit of introduction. So our journey begins at the stage where a typical company that wants to become data-driven and wants to start the data transformation decides to hire a data scientist. And they give them the first project, and that successful data scientist is starting to crank the data, work on the model, and maybe later the data science team is expanded. You hire more people and start working on more projects, and then you suddenly start to feel that your pains are growing. And the data science community starts to see that access to data and services is really hard. Collaboration is difficult. And productionizing the models that they finally produce is really hard and complex. And also the organization starts to see that project portfolios are missing, that governance is lacking, and maybe the infrastructure that is supporting all this is not flexible. So at this point, a typical organization will want to start asking themselves a question: how do we move from this mode where we're basically operating on a level of single project in a not very professional environment, and how we go from this setup to a setup where we have a robust machinery and environment that allows us to support many complex and complicated use cases in a compliant and robust way. And we'll go to the topic of our discussion now. And of course, the solution is going to be, all you need is a data science platform. But is it really that simple? And how do you go about selecting your data science platform? So one way to start is basically looking at the compilations available online of different technologies that you can choose to create or compile your data science platform. But is it really so simple to pick anything from that compilation? And the obvious answer is not, because this landscape is so complex and constantly growing. You have new players on the open source side, and new companies emerging, and major cloud providers adding more and more services to the portfolio. And deciding on what you should pick from this landscape is a really hard thing to do. So the other thing you can do is go to one of the research done by Gartner and look at one of their magic quadrants for data science and machine learning platform. And in this compilation, you'll see a bunch of technologies displayed on the chart and grouped by some categories like challengers, leaders, visionaries, and niche players. And you may think that this very professional and in-depth analysis will help you to pick the right tool. But as you start thinking about it, you also realize that it's not all that simple. So how do you navigate that complex landscape of technologies and requirements in order to try to design the platform that will suit your needs in the best way. And this is what our webinar is going to be about. But before we jump into our 6 principles, let's start with some basics, and let's think about what a data science platform is. So on a very conceptual level, a data science platform is a compilation of technologies, technical environment, organization, and people that join together create a solution that supports data science initiatives. But if you look at data science platform from a more technical point of view, you can usually slice and dice it into different layers that altogether build up a complete solution. So you usually start with some infrastructure at the bottom that can be cloud, hybrid, or on-premise infrastructure. On top of that, you have governance, which is the set of rules and regulations that your organization enforces on a platform like that. Then you have some storage layer into which you can choose to ingest some data. You can have some ETL processes on top of this. And then you start analyzing the data and modeling the data. And once you're done with this, you're thinking about that you need to be able to expose the data in some way. And on top of that, you have your variety of use cases that hopefully, when done properly, provide business value to your bottom line. So that's how we see the data science platform on a conceptual level. And now let's go into our 6 principles. So we'll start with the basics. So number 1, design and navigation rule that we put here is identify your business requirements. And that may sound obvious, but the reality is that we are often bombarded with ads, articles from different technology providers, vendors, cloud providers that promise us, if you go with our tool, you'll have a perfect data science platform that will solve all of your needs. But the question is, why would you build something as complex as on this picture, where in fact you need something as simple as here? And you know that you need something as simple as here by looking at your business and trying to understand it. And this will help you avoid all sorts of problems. And the most important and underlying problem that is this approach will help you solve is basically avoiding waste of money when investing in things that you don't need. So again, first of all, you need to understand your business needs. And one way of doing this is looking at the evolution of data science or data analytics environment. From the early days where in such environments you are usually asking questions about what happened in a report style, to the modern days where you want your system to tell you what will happen and will give you ability to predict and give you some options to how to react in a given situation. But the reality is that companies and enterprises are in a different stage of their technical growth. So you need to know if you're here or maybe you're here. Another thing, clear goals and objectives. Are you building an autonomous car, or maybe you want to forecast your sales and this is your biggest problem, or maybe you're building a dashboard that will help you monitor performance of your production line, or maybe it's a mixture of those. And obviously, if you're building an autonomous car, your data science platform is going to look much different than if your biggest problem is forecasting. And we'll conclude this session with a bit of mantra, and this is really simple. Begin with an end in mind. And remember that use dictates needs dictates capabilities, and capabilities are solved with technology. So start with use and derive technology from that. Principle number 2, understand your users. So we know a bit about our business now, and now we need to know who are we dealing with. So we start with identifying our personas and key players that we need to take into account in our design. And we can have different profiles of users. So you can have your analyst Amy, for example, that wants to build dashboards, run SQL queries, or do spreadsheets. You can have your data scientist Scott that will obviously want a robust model training environment, will want to have access to all the libraries that he thinks are necessary and have flexibility in choosing the tools. And he will also want a big and performant GPU cluster to train his deep models. And you can also have the statistician Simon that will want to play with audit data, maybe have a simple Jupyter notebook, and a CPU cluster. But this is only the first layer of complexity. If you look deeper, you'll see that not all the data scientists are the same. So for example, for data scientist Scott, you can have different types. You can have the PhD type with deep mathematical understanding, a researcher at heart, but you can also have a more pragmatic type B that understands the business, knows a few algorithms that are key in his business domain, and is an expert with real data. So the key point here is that users with the same title may be different. So you need to go one level deeper. And in all that research, you can follow a couple of rules. So first of all, identify your key users, know what their users are doing, acknowledge that different users create different platform uses, but also avoid not talking to your users, thinking that a job role is a user, or maybe thinking that one user represents the whole user group. And most importantly, avoid not giving users what they need. And now we'll jump to the next section.
Perfect. Starting with principle number 3, I think.
Yes.
Tommy, can you?
Yeah. Sorry, some technical issues.
No worries.
Okay, you can go.
Okay, cool. Then let's continue with principle number 3, understand your technical and organizational environment. I think this is especially important once you identified your business requirements and understood your users, is to go one step deeper and also kind of have a look at what environment you are in. And these can basically consist of 3 pillars. So the first one would be obviously your business. What kind of strategy and vision does your business have? Are you aiming more towards that Silicon Valley approach where technology is really your core business? Or are you more like most of our companies in the DACH region? Do you have a different core business and trying to enable that with the technology? And also try to understand what data science in your organization means in terms of what kind of business capabilities you want to support. And with that, you kind of can derive your use case portfolio. Do you have services that you want to bring to your users, to your customers, or is that really more a bottom line use case that you're running to optimize stuff in your organization? And then on the second pillar with technology, really ask yourself what your cloud strategy is. Is it more kind of cloud opportunist, or are you cloud first company trying to achieve more and more applications on the cloud, and also try to understand what your organization's position is towards open source technology versus buying vendor products. And I think also your business really impacts kind of the deployment scenarios that you have. So ranging from you can simply deploy it in the cloud, you might have some edge deployment scenarios, or you need to run your whole data science platform on premise, could also be the case. And then taking kind of the business and technology pillars, building onto the organization itself, really think of your projects more as products. And also what we often see is that we have siloed departments within the organization that essentially need to talk to each other and build cross-functional teams, but that's rarely happening in these cases. And also have a look at the skills within your company, right? So do you even have the personnel to build such a platform yourself, or do you need help from outside? And then, yeah, maybe having one deeper look, what's also kind of we call it the hard requirements that underpin the whole context of organization, technology, and strategy, are stuff like company policies, or even regulations like Basel III that your organization needs to deal with. And it's kind of this Rubik's Cube here, that the different dimensions are not fixed at a given point in time, but they are moving on a constant basis and also change over time. And yeah, then we have this nice discussion, where can we actually host our platform, our data science platform? And it's always this question around, is it on-premise or is it cloud? And it's kind of a clash between the two worlds. And then you try to come up with some good arguments for on-premise, because you say, okay, we have hard regulatory requirements we need to take care of. We need high security standards, and maybe we even have existing infrastructure that we can start with. And then the cloud guys come around the corner and say, yeah, but with the cloud, you can really start fast. You have all the flexibility you need, and it's a lot cheaper, right? But in reality, it's not that black and white. It's more on-premise and or cloud from my perspective, and it's really one extreme of the spectrum and the other one, and there's a whole bunch of stuff in between. You can have multiple hybrid cloud deployment scenarios that you can think of, and we don't want to give you an answer about what you have to choose, but rather kind of a guideline to think about stuff like scalability. Do your use cases require scalability, and can your on-premise infrastructure provide that or not? And also security might be an important factor to consider when designing the data science platform. Another one would be flexibility, right? I've spoken about change. You probably start with a couple of use cases, but you don't know probably where you are in 1 or 2 years. So that is actually also an important criterion. Another one is maintainability. If you start building out your on-premise infrastructure with multiple GPU clusters and so on, then also again, the question arises, who maintains it? Do you have the skills in your organization to maintain it? Or is it easier to move to the cloud? And definitely one of the most important factors inside these discussions is the cost factor, which you can also consider here. And then, yeah, maybe moving to the next principle, we'll take a deeper look at the decision build versus buy, and also try to guide you there a little bit, what we've learned with the build versus buy decision. And again, it's a very binary kind of discussion in the beginning, where you say we can either build it ourselves or we can buy something off the shelf. But again, in reality, there's much more blurry and much more decisions in between, where we think you also need to consider a lot of options. And as I said, we can go from, we write everything ourselves. So you start with custom code, or you buy something completely off the shelf and go for a SaaS product, for example, and then you have everything you need. And then you ask yourself, do we actually get all the features that we need from our platform, which we discovered in principle 1 and 2, or is that something that we don't have if we build it ourselves? Another one is definitely time to value. If you build everything yourself, it probably takes longer than just buying something off the shelf. And as I said, you probably don't know yet what's happening in 1 or 2 years. So the ability to change what you are buying or what you're building is fundamentally important. And custom code can be changed to your needs very easily. But once you buy something off the shelf, the vendors promise you it will work and it will fix your problems, but in reality, even some customizations, the product will stay with its core and its core functionality. And the fourth factor is definitely the cost one, where you say, okay, if I have to build everything myself, definitely the build option is much more expensive. But again, what we experience is that there's coming unexpected costs in the buy decision, where you can also think, how do I integrate it? Who takes care of the product? What happens if I need features that are not in the initial release of the product and stuff like that? And last but not least, the people required to actually build or buy something. It's a very similar scenario where you think, okay, I need X amount of developers to build such a platform. And if I buy something, I don't need anyone. But in reality, again, we need more people and sometimes even need to rely on external organizations to help us in that regard. And yeah, as a next step, I think buying a product is not really enough. It's also really who integrates it into your environment. It's who deploys it and who operates the whole solution in the end. Okay, and then maybe let's start with a poll and try to gather your opinion on data science platforms. And the question would be, what do you think is the biggest challenge with data science platforms? Is it one that my company doesn't have a data science platform? Is it number two, data science platforms are way too expensive? Number three, I can't adapt it to my needs? Or is it for you, number four, there are too many options on the market? Okay, we have some more seconds to go.
Technical report from my side. I think I cannot vote on the poll, which means I cannot take over the presentation. So tiny issue.
I think we'll move ahead once the poll is done, and then
okay.
we can move on.
Looks good now.
If you want, I can share the results of the poll very quickly.
Yeah, that would be great.
Half of the responses were number four. There are too many options on the market. And then the other half was equally split between number one and two. My company doesn't have a platform, or the platforms are too expensive.
Okay, that's very interesting, and also kind of reflecting on the problems that we see in the industry, and also, yeah, kind of the problem statement Tomek made in the beginning, that it's very hard to navigate and kind of search for one platform that perfectly fits your needs. Cool, thank you.
Okay, so moving on, I'll give control to Marek.
Thank you, Tomek. Unfortunately, I wasn't able to vote, but I would also go definitely for number four. Let's continue.
Yeah. You should be able to.
Okay. Perfect. So now I'm going to cover the last 2 points we have prepared, and they're strictly connected with what Matthias just described about build and to buy. It's usually not enough. We also need to have the right approach on the way. And I would like to start with a story that we see quite often in our experience. We come to the company. Well, inside the situation that happened is they have the team of data scientists already, and they complain that they cannot run machine learning jobs. So the leadership, they often put their heads together, they try to pinpoint the problem, they look, they say, we probably have an Excel swamp, everyone is exchanging either Excel files, CSV files between each other. They cannot work on this data because it's a mess. So the question arises, where can we handle this data? Let's buy, assuming the company is rich enough, we can buy data lake, we can buy cluster. They should be able to do it. But then the data scientists still cannot run the machine learning jobs because, well, the data lake is not really easy to use. There is multitude of tools. There is many ways in which we can handle the computation. So there is this question, how can we actually build the solution? So there is yet another group of solutions that integrates with what we have, the data lake, and gives some sort of UI and guides easily through the creation process. But then the problem is we have permission split, right? For example, we have permission handling on the workbench side in this data science dashboard front end. We have different permissions in data lake. Security becomes messy. So the next step is to buy some sort of data loss prevention, some security layer solution that's going to, well, cover us for this case. Since those tools, they usually also require us to follow a certain access path, certain patterns, the data quickly moves around. Suddenly, we don't know even where our access that are supposed to be organized in the data lake are. So another question, where is my data now? Obvious choice, let's buy a data catalog. So as you can see, we had many problems. For each of those problems, well, there seems to be a solution that we buy. Although at the end, where we try to put everything together, well, it turns out it doesn't fit. Like the data science doesn't integrate that well with data lake. Then we need to integrate both with the security. Then when we try to plug data catalog to everything we had before, it's like basically unfitting puzzles. So one philosophy I'd like really to underline in this webinar is never try to think about buying a solution to your problem, because perhaps the solution is already there. There are some existing standards, existing solutions inside the company that we could use to not introduce this unnecessary complexity. Perhaps the data scientists, all they need is Jupyter notebooks, like we have many times observed. They just need to plug over Jupyter to the cluster, they are good to go, and maybe some scheduler. Or in case of data, quite often the data is small enough that with good governance in even simple dashboard showing what is where, it's enough. We don't need super sophisticated tools to solve problems on a small scale. On another front, we have a little bit of an opposite approach. Like we've also seen that there is a super convoluted design doc covering every single use case, every single possible scenario, and companies happy we have planned it perfectly. But then when it comes to implementing this 125 pages design doc, well, it turns out that one of those components is not really what it should be. It's missing some features, something is crooked. And then we have all these exercises of stretching, moving, shuffling, and so on, trying to fit it. So the approach on the completely opposite pole is also not really there. What we usually suggest is there are some foundations that we need to have. We need the place to store the data. We need some way of handling. We need to cover the basics about which Matthias and Tomek were talking about. And then we need to leave options open. So we have usually a couple of ways on which we can solve problems. We should look at them, evaluate them. Perhaps some of them are obvious candidates that we can recommend. Some of them, well, maybe they have drawbacks, but we shouldn't rule them out at this point, because perhaps in the future it turns out that they can solve our problem and actually be better. That's something that seems like an obvious choice. And at the very end, we have tools that obviously, for example, break completely our security, don't fit in the company model, organization, those we can simply reject. And moving like this on every step, considering every possible approaches, we can quite, I wouldn't say painlessly, but we can navigate toward the solution that would try to satisfy everyone. To be mindful of time, I'm not going to go over this slide in detail. One thing I just wanted to point out is, again, the right approach would start with users collecting the data and analysis. Then what we find out works, especially in case of this small to medium enterprises, is nail it, then scale it. So we try to solve the problem with one use case that's going to work. Once it works, we can scale it. We can try to apply it to more and more and more use cases and keep building on top of the foundations we have. And one important point also, at no point we should forget the non-functional requirements, because it's easy in the heat of the moment to forget the regulatory requirements, the necessities, and so on. Some of them can be postponed after day one, but if we postpone them until like 1, 2, 3 years, at some point they are going to be back and they are going to be painful. Yet another, I'd say, philosophical slide, that we don't just build once and forget our solutions. So our data science platform, even when we think it's feature complete and it works, there are forces that are coming that might trigger us to think maybe it's time to change, maybe it doesn't work anymore for this case. We should, every time we see one of those forces, we should ask ourselves, is it actually a problem that belongs to our platform? Maybe it should go someplace else. Is it really that we do not have enough solutions, or are we just looking for an excuse to try out something new? And actually, is it already the time to work and build? Maybe we can also wait a bit, see what's going to be possible in the future. And this should always prompt us to ask why. Why is this happening? Why am I having this problem? Why is it not working for my trouble? Maybe it's governance that we could a little bit tune up and it's going to be already working. Maybe it's some issue in the organization with teams not being organized in the way that's corresponding to our platform flow. For example, we quite often see that we have this split between business and IT people. And then there is a lot of complaints that the platform is too difficult, but it's not the problem with the platform, it might be the problem with the org. If we find out that we indeed need new tools or it's a scalability problem, we go back to what Matthias was talking about. Perhaps what we bought is not anymore the optimal approach. Maybe we could replace a tool that we bought with building it. Like, for example, in the case of Dropbox, that at some point the S3 for Amazon turned out to be too expensive for them. They decided to build their own storage from scratch to save costs, actually. So at every time we have to reevaluate, we have to constantly ask ourselves if this is the right moment to change. And when we apply changes, we have to remember to go with them back, update our architecture, update governance. Do not forget about the legacy to let it be there and grow there. Last point, which I'm going to cover really super quickly now, is the adoption of the platform. Basically, platform is a product. It's something we want to roll out. We want people to embrace it. We want as many people in the organization to use it. This is why we should first be aware of what's happening, define metrics to see if it's going to be successful or not. Two, we should have growth tactics, which means onboarding easy. So people should be able to authenticate. They shouldn't be routed through 10,000 tickets to get access to data platform. The onboarding should be there, that some basic setup should be pretty easy to reach so that they can have a look at it. And then marketing. Platform is a product, so we can market it internally inside the company. And this is an approach we see also gaining momentum recently. So a little bit of a glitch in progressing to the next slide. We see the so-called COE, which means Center of Excellence, as a quite successful setup, especially in the big organization this time, which basically consists of people specialized, cross-functional, around this platform that are having all the necessary skills to help business units bring their, whatever it is it a use case, is it like some AI problem, is it an issue, to the platform, have expertise from people that are the platform delegated, and help them to see if it's the right match, if we can build a product on top of that, and how to progress with the future. And like that, the business users, which should be customers actually of our platform, are going to be happy. And like in any business, customers are going to spread the good news and bring more business to our platform, more use cases, more information. And just to sum it up really quickly before we move to the Q&A, recap of the key messages we three thought you would really take with you. And first and foremost, platform is a product. It's not a single project that we do and forget. It's something that grows. It's something that evolves. It's something that changes. It's something that has customers. It's something that we have to sell sometimes inside our company. To sell it and to grow it, we need to understand our users. We need to understand their needs, and we need to understand the organization, if it's going to work and if it's going to fit. While doing that, we have to remember about regulations. Otherwise, they might really come back and bite us if it's something long time neglected. And what I was talking about, tools are never the solutions, or just tools are not the solutions, and neither are super detailed design docs that are written by some, I don't know, maybe sometimes external company that tries to give you a boilerplate instruction of how to succeed. It's always has to be tailor-made, and it always has to evolve together with your product. And last takeaway that we have prepared is to promote, since platform is a work of art. I'd say it's something you want to keep growing inside your company. You have to remember about doing marketing, about promoting it, about making users or members of your company aware of that. And with that, I would like to thank everyone for your attention and ask if we have any questions. Samir.
Yes, we do. So we've regrouped them a bit, and the first one is, so say that in-house data scientists are afraid that such a data science platform is going to limit their capabilities. How would you address that with them?
So it can be the case, right? This is why we were talking about designing the solution. The more software as a service we go, the more opinionated the approach is. This is why, again, finding the right balance between flexibility and software as a service is going to be the answer here. Tomasz, would you like to add something?
Yes, and maybe to add to this, I would say that sometimes it's a matter of trade-off. So it is possible that some, with the new tool, new platform, new design, people that are used to do things in an old way will lose some of the things that they like. But on the other hand, they may be gaining some other things that will overall make them more more effective. So it's always a trade-off, and also a matter of how you market and your product to the end users.
And then let's say that beyond the marketing aspects, what sort of capabilities does an organization need to successfully run a data science platform?
Probably from my perspective, it needs to challenge the status quo, right? They have to admit that something is not working. And I think another one is cross-department collaboration. Because what we see is that sometimes data scientists, they work inside the business units, and then you have, as Marek said, you have a big IT organization which is basically responsible for providing the platform, and there needs to happen a lot of communication. And let's say the more traditional companies are not really used to that kind of product approach, also to that designing your approach, and touching upon the first question, talking to your users, right? If you don't talk to your data scientists inside the business units and don't ask what they need, they will probably then in the end not use your data science platform if you just give them something that you bought off the shelf.
Thanks. And more questions that are really grounded in experience. So this case, we're not connected to or using any cloud yet. Would you suggest to choose a cloud solution as a data science platform?
And here the answer, I guess, usually depends on the circumstances. So there's no easy answer for this question. But if your data regulations and policies within your company allow you to go to the cloud environment, even if you're not connected or onboarded in the cloud environment, it's usually a good place to start with, because that cloud environments are usually feature complete and give you a quick ramp up time and allow you to play with different approaches, different tools, and to really validate your assumptions pretty quickly. And if you're happy with that, in a quite cost-effective way, you can do the validation and then move on to a more advanced setup with like full cloud onboarding. So to summarize, I would say we would still advise to go with the cloud deployment if your organization is ready to do the step, even if you're not yet connected. And which cloud provider you choose, this is really this really depends on many aspects, features you're looking for, a style of working, and your already existing partnerships. So this is also quite specific to the organization and situation in which the organization is.
Thanks. And then one final one, and I think this one applies to a lot of companies, even a lot of companies that we see in our daily business. So say we don't have access, central access, to different data sources that are spread all around. Would a data science platform help with that?
So I think here you have to go a little bit before the data science platform, because already if you have data, well, it's very frequently the case that you have data silos inside the company, and there is a couple of approaches. But before actually data science platform, I'd say you have two options. One is a data mesh. It's a huge organizational effort, but basically each of the silos should be exposed over some unified API that's going to work basically on a silo per silo basis and allow to communicate with that. Or in a simpler scenario, you could have the classical concept of a data lake before, where you bring all the data in, and then on top of that data, you are building your insights. Because if you start with a data science platform, how are you going to feed it? It's usually built to solve the problem of working with data insights, but the data needs to be somewhere.
Well, thank you. Then thank you guys for the engaging session. We're just perfectly spot on time. So thanks also everyone who attended and that wanted to learn more about the design consideration of data science platforms. So as promised earlier, you received a recording of the session via email, and all the past episodes are on YouTube. We have more webinars coming in, one in May, one in June. Stay tuned on our social media to learn more. Thanks a lot from Unit8, and have a great evening, everyone.
Thank you.
Thank you very much.
Thanks.